It's me Chiku from Chiku Study Corner. Today we'll be dealing with Chapter 9 of Physics, Class 12 CBSE, that is the Chapter 1 of the second textbook. The name of the chapter is Ray Optics in Optical Instruments. So, we defined what was ray optics and what is optics. We defined what is a light, what is a ray, what is a beam, and what more about light. We learned about its 7 properties. Out of which the 7 properties we learned in almost in depth of reflection, and now we have to learn about the optical instrument. But since reflection is not there for our 2021 board exams, I'm not going in depth to it. Now for ray diagrams for both lenses and mirrors are so important, and we'll be discussing about that first, the rules for ray diagram, and then we'll continue. And we also dealt with what is refraction and what's absorption, and usually there are 2 types of reflections. What all are the 2 types of reflections? One is regular and irregular. Regular reflection is also called as specular reflection, and irregular reflection is termed as diffused reflection. These all are what we dealt in this previous session. So now let's see what we have to learn in this session. So let's get started. So let's start drawing. Before we get into each of the rules for drawing a ray diagram, what we're going to do is we'll just again go through the structure of a spherical mirror. This is same for lenses as well as for a plane mirror, but I'm just discussing it with a spherical mirror. This is our mirror, this is the non-reflecting side, this is the center of curvature C, and this is the pole P. The line joining these two, a straight line joining these two, is called as what? Principal axis. And then what else? This pole and the center of curvature. The half of it, the distance or the point between them, is known as the focus. Okay? So with this much, let's start doing our ray diagram. And this is the reflecting surface. In the first rule, we have to say about a light ray that is falling parallel to principal axis and it hits the mirror. So if a parallel ray falls on a mirror, it should be parallel to what? It can be parallel to anything, no? It should be parallel to the principal axis. So if it is parallel to the principal axis, it will get reflected in such a way that the reflected ray would pass through the focus. Like this. Okay? So the reflected ray would pass through the focus. This is the first rule. The second rule is the right opposite of this. What? If a light ray is falling from a point which passes through the focus, it will just go parallel. It will reflect back in a parallel path towards, parallel to principal axis towards the opposite side. See, if it is like this, it will go like this. So this is the first 2 rules. I hope this is clear to you. So this is parallel, and the image or the image formation of the object is coming from infinity. Now let's move the object on this principal axis to see what all kinds of images or what all kinds of rules we have to learn for our ray diagram drawing. This was in case of a concave mirror. What do you mean by a concave mirror? Where the inner surface of a sphere is the reflecting surface. So for a convex mirror, let's see. Let's wrap this and draw for a convex mirror. How will a convex mirror look? A convex mirror would look like this, with the inner side to be reflecting. And let's take, this is the center of curvature, this is the foci, this is the pole. Okay. And by the way, what I forgot to mention is, when we were learning about the reflection in a concave mirror, what did we learn? We learned that when it's parallel, it will pass through the focus. But when the rays are coming, when you draw a normal, the normal would pass through the center of curvature. Because center of curvature, when you draw the line to any point on the mirror, it lies as a normal. So let's see for what happens in a convex mirror. So this is the principal axis. For a convex mirror, this is the reflecting surface. The light would come, if the light is parallel, and would come and fall on our mirror, what happens? There would be a reflection in such a way that if you extend it or extrapolate it, that reflected ray would join the focus. This is the focus, this is the center of curvature, and this is the pole. So what would happen? A parallel ray is falling over the mirror, and what happens? It will get reflected such that if you extrapolate it backwards to the back of the mirror, it seems like it will coincide with the point focus. Okay, and the normal would be the center of curvature. See, isn't it the normal? Therefore, what happens? Angle of incidence is equal to angle of reflection. So actually, this point in the spherical mirror act as a plane mirror. So what would happen if it was the other way around? Let's take. If the light ray is falling in such a way that it seems like if you extrapolate it, it seems like it will go and hit the focus. Then what happens? It will reflect in such a way that the reflected ray is parallel to the principal axis. I hope this is clear. This is to talk about the first rules that comes under both concave and convex mirrors. I hope this is clear. So let's move on with the next rule. So let's see. What is the next rule? We have to take a spherical mirror. We'll draw both of them now. From now onwards, we'll draw both of them and then we'll learn. So this is the poles of the mirror. This is the center of curvature of this mirror. This is the focus of this mirror. This is the center of curvature and focus. So let's draw a line. So this is the principal axis. Now let's take this to be a concave mirror and this to be a convex mirror. Okay. So what are we going to do is, first let's take a light ray is passing through the center of curvature and it hits the our mirror. Then what happens? Then there would be a retracing of path. If a light ray or a light beam falls on a mirror passing through the center of curvature, then what happens? That will reflect or that will retrace its path. Retrace its path means it will go like this. If the line went like this, it will come back like this. Okay, but we say the line is moving in a straight line, so it will go hit the mirror and it will get traced back. Okay, that is what is happening. So why is this happening? Because we know the center of curvature. When you join a point from any of the portion of our mirror, you will get that line to be your normal. So you can see our normal as well as our incident ray are coinciding, which means our angle between the ray and the incident ray and the normal is 0. So angle of incidence is equal to angle of reflection, and hence what happens? The retracing of path happens. So for a convex mirror, let's suppose this is our line. Okay. If a light ray falls on this, if a light ray is falling on a convex mirror, and what happens on the convex mirror? In such a way that the light ray is assumed or it predicts to be passing through the center of curvature, then it will retrace its path. Why is it the same reason? Angle of incidence is equal to angle of reflection. So from this, what did we infer? From all these ray diagrams that we drew, what did we infer? We infer that all of these obeyed the laws of reflection. There was that. What was the laws? The incident ray, the reflected ray, the normal, all three lie on the same plane. All three was lying on the same plane because it is from that single point all three originated. And then what was the other one? The angle of incidence is equal to angle of reflection. So a very common phenomenon. Is it always possible for these rays to fall through these lines itself? No, it might not fall always on the same principle. So what happens? So let's draw a mirror, and this is the principal axis, this is the pole, this is the focus, and this is center of curvature. If a line falls on the pole, what would happen? Creating an angle theta with the principal axis, then it will reflect in such a way that it will form another angle theta. Okay, that is angle of incidence is equal to angle of reflection. Am I right? This is how we draw ray diagrams. So next we have to learn about sign conventions. What do you mean by sign? Sign is whether it's positive, negative, or how do you say this entity is positive, this entity is negative. So let's see that. So let's see the sign conventions. So let's take the graph. This is our graph and this is the mirror. This is the pole of the mirror. Okay? This is the pole of the mirror. Anything towards the left is positive, and anything towards the right is negative. Okay, this is our left side and this is the right side. And anything above, or let's say this is the, what do you say, principal axis. Anything above the principal axis is taken as positive. Anything below is negative. Okay. This is actually implied for both. Okay, even this is implied for both. So what did we say? What all are the sign conventions? One is that when you move from, this is the pole of the mirror. So let's take an example. Okay. I'll just simply describe or just give you a small example. We'll go in depth when we are learning more about ray optics. So this is our mirror. Okay. So let's make this a convex or a concave mirror. I opt for a concave mirror. So let's draw a concave mirror. This is the principal axis. This is the reflecting, non-reflecting side. And, okay, this is the focus. This is the center of curvature. And, let's say here, the focus and the center of curvature, the focal length or the distance between the center of curvature and the pole is taken to be negative because this is towards the right of the our Cartesian plane. If we take, this is the mirror and it's towards the right. So let's take for example, I keep an object here. So this distance between the pole and the object distance is taken as negative. And if I get an image right behind this, somewhat like this is also negative. Instead, if I get an image to the front, it's taken as positive. So I hope this is clear. So now let's see the formation of these images on a concave mirror using the rules of drawing ray diagrams. We learned 4 major rules. What were it? We said when like light ray which is parallel to the principal axis is falling on the mirror, they would get reflected in such a way that they will pass to the focus, and the other one is when they pass to the focus, they will hit and go by a parallel line. Or if it goes through a center of curvature, what will it do? It will retrace its path. And one more we learned, at any point, one angle of incidence is equal to angle of reflection. So this is all that we have to learn. So we'll define the image. Like we don't have to take every point of an object. We'll start with a linear object or a point object. So as to get a basic idea on how you can form an image on the other side. So let's get started. So for a concave mirror, we're drawing the concave mirror, we're drawing the ray diagrams. So let's see a concave mirror, and what will we do? We'll adjust the points at which the image is found. So I'm drawing the principal axis. This is the point or the pole. This is the center of curvature. This is the focus. And that's all that we have to write now. If you want more, we'll mention it later. So, let's start from the further. So, from infinity, we are taking an object. Okay? From the infinity, what would happen? We'll take a light ray that is falling parallel, as well as that we'll take a light ray which is passing through the center of curvature. Okay? So, one is falling through the center of curvature and will get reflected back. So, what will happen? This will go like this and this will get reflected back. The same way, this light ray would go like this and would pass through the focus. So, what will you get? This is a point on the top. Am I right? Is this a point on the top? And therefore, what will happen? At this point of intersection would be the top portion of this object. So, it will become like this. From this, what do you infer? You get a real and an inverted image. This is a real image because the lines are actually intersecting and there is a real image and it is inverted and it is what? It is small real inverted image. And at what point or at which point do we get this? This somewhere between the center of curvature and the focus. Okay. Now let's move this person to the center of curvature and let's see what will happen. So, let's take the next position, that is our center of curvature, our focus. Now our object is in the center of curvature. So, as before, it will pass through the focus. Let's shift the focus. Okay, it will pass through the focus. And also, what would happen if it has to fall through the center of curvature? There is no point like that. So, we will take one where it interacts over here and would go like this. Okay? Because this is angle of incidence is equal to angle of reflection. That is how I have taken this, because in the center you cannot have a point at which the light falls through the or from the center. So, let's say this is our two rays. The point at which they intersect, okay, would be like this. And we would get an image in the in center of curvature itself. At that point, we'll get an image which is a slightly bigger one, and also what this would be an inverted real image. Okay, this is what happens when the position of the object is moved towards the center of curvature. So, this is the object and this is the image. Okay, I hope this is also clear. Now, let's move the center of curvature furthermore and keep it in between the center of curvature and the focus. So, let's see. So, this is our principal axis. This is the center of curvature. This is the focus. This is our object. Am I right? Yes. So, as before, we are taking the same ray, which is that parallel to the principal axis, falling through the focus. Am I right? And over here, how would you take a line that passes through the center of curvature? It seems to pass to the center of curvature. Is that what we can take? So, let's take it like this. Am I right? Okay, let's extend the mirror. So, it will go like this, and what will happen? It will retrace its path. So, it will go like this, it will hit and it will retrace its path. So, it will move like this. Am I right? So, at a point, they will meet at some point in the end. And what will happen? They will form a real inverted and a huge image. It will be very huge image. Because you can see that this doesn't join anywhere here. So, when it forms, what will happen? It will form a big image at infinity. I hope that is clear to you. So, that is what is happening at the center, at the middle of center of curvature and the focus. I hope this is clear. This is to talk about this, case. Now, let's move this object to our focus and let's see what happens to the image formation. So, let's draw. This is our mirror and this is the non-reflecting side. This is the principal axis. This is the pole. This is the focus. This is the center of curvature. Am I right? Now we are shifting it to the focus. So over here, I am drawing it, and this is our object. What will happen? It will hit and would fall through the focus. It will go like this. Same way we are taking another one. You can either take like this, the one that falls or that seems to come from the center of curvature, or you can do this one according to your wish. Okay. So when you extend it, what would happen? You will get an image that is between the center of curvature and the focus. Okay. This is according to angle of incidence is equal to angle of reflection, the law of reflection. Okay. I hope this is clear to you. So when an object is placed in the focus, it will form an image in between what all the center of curvature and the focus. And the next case and the last case to discuss under what the concave mirrors or the concave mirror reflection is when this object is placed between the pole and the focus. So let's see how is that. So this is our mirror. This is a non-reflecting side. This is the principal axis. This is the pole. This is the center of curvature. This is the focus, and here is our image. So what would happen? This would hit and would fall through the focus. Okay? And also what would happen if you take this, what is happening? This is parallel. Angle of incidence is equal to angle of reflection. That is what you have taken. This is parallel and hence it won't meet. So what will you do? You will join the points like this and you will get a virtual, enlarged and erect image when you keep that between the focus and the pole. I hope this is clear to you. So these are the cases that we have to learn under what the ray diagrams of a concave mirror. So I hope it's clear. What all were the cases and where all does the image come? So over here, what is this? Only in the case where it is close to the pole or it is in between the focus and the pole, you get a virtual, virtual enlarged erect image. That is like this. Okay. Now let's revise what all we dealt with the ray diagrams. The different cases. The first case, at infinity, the position is kept. Then the image would be at the focus. The nature of the image is real, inverted and diminished. Diminished in the sense it is of a smaller size than that of the object. Second case is the object is beyond the center of curvature. Then the position of the image formed is between the focus and the center of curvature. The nature of the image is real, inverted and diminished in this case. And when the object is at the center of curvature, the image formed is also at the center of curvature. It's real, inverted and of the same size. The fourth case is when the object is placed between the focus and the center of curvature. The image formed is beyond C in this case. So, the nature of the image is real, inverted and enlarged. The fifth case is when the object is kept at the focus. The image formed is at infinity. The image formed is real, inverted and highly enlarged. And the sixth and the last case is between the focus and the pole. The object is kept between the focus and the pole. So the image formed is behind the mirror. And the nature of the image is virtual, enlarged and erect image. I hope you might have understood it and liked it. If you've understood it and liked it, please give my video a huge thumbs up and also subscribe to my channel if you're new to it. And share my videos with your other friends. So if you have any doubts or queries about this, please do leave it in the comment box. I'll be answering there. So see you on the next video. Till then, bye.